we were kind of allowed to choose our subject combinations. So we had to choose like something like 3 or 4 advanced level subjects called A-level subjects. So during the time when I was a student, I had wanted to do mathematics, further mathematics, biology, physical science. But there was no such combination. So I went to the vice principal at that time and said that, oh, can I do these subjects combination? And she said, no, she laughed at me. She said, ha ha ha, nobody does biology with further maths. They don't go together. And so I asked for the reason, and she told me that, in the GCE A-level examination, biology and further maths will be taken at the same time on the timetable. So you can't split yourself into 2 and take the same paper, right? So, okay. So I had this impression that one can't do biology with further mathematics. But then, when I went to the university, it was University of Adelaide, as you can see. Here. I came across this topic, and I was very happy to do it. And now it's my turn to back to the vice principal and see, I did it, mathematical biology. Anyway, if you think that this is not the real, this is very authentic, right? You can see that my name is written with the family name at the end, as Australians would want me to do. My surname is there. And if you think that this is just a model of the real thing, I have the real thing from 25 years ago. So I want to flip through the first few pages to show you that in the entire first chapter of this honors thesis, there was no mathematics at all. I was just talking about biology, about the biology of blood and circulatory system, the human circulatory system. So, what did I have to do in this project? Basically, the problem is to look for an appropriate model for blood flow through elastic arteries. And at that time, there were already a number of models available, but they were not really physiologically very accurate. So my problem at that time was to look for something that is more appropriate, taking into considerations some of the assumptions that have been made in the other existing models, and then maybe re-looking at those and re-examining those assumptions, studying those assumptions, and coming out with a better model. So I had to do a lot of background reading. I have to study the biology of blood, circulatory system, arteries, flow, looking into, I didn't know what was non-Newtonian flow. I had to look at and look it up and study on my own. I had to examine existing models by reading journal articles and so on, question those assumptions in these models, reconstruct models, solve those equations, present the solutions orally, and then write a report. And if you want a product, that's the product. Now, maybe we look inside into what I had to do. Now, one of the problems that I had to, there were many problems, If you talk about problem solving and mathematical modeling, there were many problems that I had to solve, but this is just one of them. So one of the problems that I had to solve was to look at this table here down. This table gives the values of the tension versus the strain, or the stress versus the strain in an elastic artery. If you imagine elastic tube, as you add more and more weight to it, it will start to stretch, right? It stretches. So the amount of weight that you add is basically the tension, equivalent to the tension in the artery, and that is the amount of stretch, the strain. So these are experimental values, and one of the challenges is to then, can we represent this by some kind of a function? Now, the existing model that I was looking at had this relationship represented by degree 5 polynomial, and I thought that was not good enough. So I generalized it to an exponential function. And when I tried to then fit the exponential function through these points as best as I can, I realized that I was stuck. I didn't know how to do, because basically, not sure if you can see, the function turned out to be like this, is nonlinear. So I had to do some kind of nonlinear regression. Now, I was very bad at statistics. I'm still very bad at statistics, so I didn't know how to approach this problem. So I did it. I was stuck for about a month, and I studied the problem. And in the end, I thought I would just devise my own way of using least squares method by using some calculus and so on, and looking at the sum of residual squares and trying to minimize that sum of residual squares. Eventually, I came up with an algorithm, a procedure, to minimize that SRS, or sum of residual squares, and obtain those values as the parameters A and K in the model. Right? So it took me a long time, a month, to solve the problem. Now, I shall attempt to solve the problem again, but it will not take a month. Okay? I will use technology, Excel, and I will show you how it can be done very easily. So that's the data set. So that's the strain. We put that on the so-called the horizontal axis. So this is the graph. A couple of days ago, Professor Graham Wake told us that a graph is worth 1,000 equations. So that's a graph. Yeah. So I've put all these points there, and that's the data here refers to the value of the stress, all right, or the tension. Okay, so basically I have to fit this curve in, and I have to find the values of A and K. So suppose I just assume at the beginning that my A is 1 and K is 1. Of course, these are not probably not the right values, but let's suppose those are the values. And what would my model look like? So if I were to use the formula, now this is already A and this is K. So using Excel, I'll just say this is equals to A times exponential K times X, right? Take away exponential K. So that's the value, and I just copy this down. So can you see at the moment with A equals 1 and K equals to 1, that's my graph. It's very bad, right? Okay, what can I do? The next thing I do is that I try to find the error in my model. But as we all know, if we try to find error, we square the error so that we do not get negative values. So that formula will be if I take the difference between the data and my model value, and I square it. Okay, so I just take this value or this formula, copy it down, right down there. And can you see this huge number right at the bottom there? That is the sum of all the squares there. Now that may be too large a value to handle, so let me just take this value and divide by the number of data points I have. I think I have 15, to find some kind of an average error. So my objective now is to minimize this average error, right? So this can be done in Microsoft Excel or any other spreadsheet very easily by just highlighting that particular cell and using the solver tool. Right up there. Okay, so you click on this cell, click on solver, and then it